Hello everyone, good afternoon. Today I'm going to share some thoughts regarding eye tracking and 5G, of course the XR. So my name is Hai Yan, so I'm from the 7invensun. So let's get started. So first, let me introduce what's the eye tracking. So basically, the main purpose of eye tracking is to get to know of a person is looking at, where he is looking at. So there are a few steps in order to get the gazing point of a user. So first we have our First we have our eye tracker devices, which is encrypted with the infrared light sources, also the image sensors. So the human eyes will reflect the infrared light sources, and then the images of eyes, including the refraction, will be captured by the image sensors on the eye tracker. And then our algorithms running on the PC, on the computing devices, will get the image and do the analysis, and it will do the calculation to estimate the point of gaze, what exactly the people is looking at. So next, let's look at what is eye tracking can really be used. So basically, this video here shows you can use the eye to just typing the keyboard. You can select the letters from the virtual keyboard. It's one, and this is the a text. Basically, if you are using the eye tracking devices, basically we can tell what you are looking at. And for example, this is a text experiment where we were doing, and you can of course using other experiments as well. For example, the pictures, the videos. And also here's the game, and you can use your eye to just play some games. This is whack-a-mole. You can just use your eye to just whack-a-moles. So those are pretty interesting applications we can use. The eye tracking can be applied to. So what are the challenges in eye tracking technologies? So first of all, for eye tracking algorithms, it needs to perform all kinds of calculations in real time. By real time, I mean because we want to get know what people are really looking at, especially when you are doing the user interactions, you need to react fast. So that's one of the challenges we are facing in the eye tracking technologies. The second one is the robustness and the versatility. So basically, by robustness, I'm talking about because people have different of course have different shape of eyes, and because our algorithm currently is based on the 3D module of the human eyes. So each person will have different modules, so they will impact the accuracy of our results. So we have to find a way to adjust different shape of the eyes of different people. And the third one I listed here is the energy consumption, basically the efficiency of how the energy can be used. So because our eye tracking normally will use for the mobile devices, for example, the VR headset, also the AR glasses. So the energy consumption is also one crucial factor we consider in our design of the solutions. So nowadays, the deep learning is also playing key roles in different applications, and we also try to apply the deep learning for eye tracking purpose. So we have our own processing pipeline for applying the deep learning to get the point of gazing. So first, of course, we're doing the face detection, and we find the landmark on the face. We need to find the eye area, and we have our own trained model to get the estimation of the pose of the head, and also the direction of the gaze, and then we sort of fusing those two to get the sort of accurate estimation of what people is looking at. So in addition to that, we are also trying to, because I mentioned like the machine learning based like algorithms, we want to build a largest like eye image database. So basically, by utilizing our devices, we can get the eye images from different users. Then we build our own like database for the training purpose. And we have the eye capturing. Basically, we stored all the eye images captured by our devices. And then we also do the segmentation. Basically, we want to see like what's the real part of your pupil and the iris. And then we can use those as the marker for the training purpose. And because the collection of the training data is kind of costly, we also want to do some automation of the process so that this can be easily done with minimal cost. So let me just give some introduction about our competitiveness of our company. So we have like a bunch of engineers who are working on the theoretical and the engineering of our algorithm design. And then we also start earlier in the deep learning study to be applied for these eye tracking solutions. And and we also cooperate with like universities who has more knowledge for the human eye like structure, so that we can adjust our algorithms to be able to have better estimation of the gazing point. And we also like invested a lot for the intellectual properties. And currently, we already have like around 10 million frames, I mean the images in our database from different kind of people in terms of eye images. So that is a very good opportunity for us to do the deep learning on those database to get our eye tracking module. And our company has been founded like for 10 years, and we focus exclusively in eye tracking technologies. So that's our kind of like commitment to this direction. Of course, the 5G is coming, so it provides us lots of benefits. For example, the high bandwidth, the low latency, and the Internet of Things. So I think with all those applications, the eye tracking can, of course, be applied in many different use cases. I'll give you more details about what are the use cases. And those are the sort of like features of our solution. We can have a wide field of view range. For now, it's around like 110 degrees. And our algorithm can be run like less than 1 millisecond on, for example, the Qualcomm like 845 platform. And our frequency can be achieved around like 120, and it can be upscaled to like 300 frame per second. And our SDK can support multiple platforms, including Windows, Android for the mobile platforms. And we have the full support for the SDK and APIs. So the app developers can easily use our APIs to develop their own like applications to utilize the eye tracking technologies. And we also provide the full range of data to researchers who is doing study for the human behaviors. So we provide for example, the radius of the pupil, like the fixation, the saccade, and the intention, the intensity, all those stuff. And yeah, as I mentioned, so our algorithm actually, we have been working on the optimization of our algorithms on different platforms. For example, the NVIDIA RTX, this is for the PC, and the Snapdragon 845, those are for the VR headset, and currently the XR1 chipset, also we are also working for the AR glasses. And this is the architecture of our solution. So basically, we provide like solutions for different AR, VR devices. And we have our own SDKs. And then those SDKs can have multiple platform support, Windows and Android. So underlying, they have like a different like hardware chipset support. And this is the one of the crucial applications in VR. This is called the foveated rendering. So if we can get the sort of accurate area of what people is looking at, then we can just do the high resolution rendering for a very small area. And we can use like low resolution for the rest of the area, so which can greatly reduce the power consumption and the computing resources needed for better user experience. And yeah, this is the application I just showed you guys. So we can have like user interaction for some gaming. And we also can have like, this is the AR application of the gaming. So basically, you can use the eye as a sort of like additional like interaction tool. Okay, this is for the eye movement analysis. So the researchers can let the user to wear the VR or AR headset. Then they will find like what people are looking at and how long they are staring at specific point or area or object. Then afterwards they can do the analysis based on the data captured by our devices. So they can come up with solutions, come up with conclusion about like if this, for example, if this arrangement of the virtual retail store is actually what people really want, and how about the design of this prototype product, if the people really like it or not. And these are also other applications. We have the avatar, who will mimic your your eye movement, for example, the blinking and the rolling of your eyes. And we can also, in our like VR headset, we integrated like the iris recognition. So basically, you don't need to manually put your user ID, and it can be automatically be recognized by our devices. Then it can automatically pull out the user profile for user. So yeah, those are our partners. So we are working closely with VR, AR, and chipset manufacturers to provide the eye tracking solutions for our customers. So also we have cooperated with some like universities who do the training for the Olympics. So as I mentioned, we also have close cooperation with universities. They provide us with the more accurate eye modules for us to improve our algorithms. So these are our product lines. So we have like assistive devices for communication. So basically these are for the disabled people. So it's not convenient for them to use their hands or just speak. But they can use their eyes to just communicate with the outside world. So they can use the eyes to select menu. They can even write a book with the help of the assistive devices. So this is our eye tracking solutions for eye movement analysis. So we have like kind of remote analysis. Basically, the user, it's not necessary for user to wear anything. He just needs to look at the screen. Then our devices will be installed like under the, for example, the PC screen. So you can design like experiment by telling like what people is looking at and by which order. You can do the behavior analysis. And we also have the latest product, the glasses eye tracker. So basically it's just like a normal pair of glasses, but with the capability of knowing what people is looking at. So the right corner one is our solution for the AR glasses. So basically it's a clip-on design. So with any AR glasses, you can just clip on our frame this module, so you can enable the AR glasses with the eye tracking capabilities. And these are more applications. I'm not going to go through each one of them. Yeah, and we are also working with like the eye tracking solution for smartphones. So basically, people are, especially in China, people sort of using smartphones basically for everything. We thought it will be much convenient for people if they can use their eyes to control, like, for example, the menu. When they're reading books, they don't need to swipe up or down. They can just use their eyes to like look up, then it will be automatically flip up. So those are kind of like use cases we want to target for the smartphone applications. Currently, we are studying the machine learning algorithms so that we can enable the smartphones with these eye tracking capabilities. Those are different like approaches we have been tried for the smartphones. And those are the even more applications. So I've talked about like gaming, and the single hand control is just like you can use your smartphone. You don't need to swipe up, down. Especially one, for example, if you are cooking, right? If you're cooking, you have both hands occupied with stuff. So if you are looking at some recipe, you can just use your eyes to scroll up and down. I'm just throwing out some like example of use cases. And you can, of course, you can use your gaze to control, unlock or lock your phone. Yeah, and also recently we are seeing more and more applications for the smart driving. So we can use eye tracking technology to detect the fatigue of the driver. And especially for the smart driving, I mean, nowadays people are thinking about a huge display to be equipped on the cars. So how you're going to interact with them is kind of challenging, right? You cannot drive and at the same time to try to press some button, especially when they are far away. And I think eye tracking is kind of possibility for people to easily interact with those like screens, menus on the car. Okay, this is our milestones. It's a long way for us. We have like been working on this field for 10 years, and we started with the assistive devices for disabled people. Then we launched our first solution for VR headset. And now we come up with our latest product, the wearable like eye tracking devices. And also for some existing VR headset, we developed the kind of plugins so you can just turn your existing VR headset into someone which can do the eye tracking stuff. So it's pretty cool. And thank you. I'd like to answer any questions if you have. Thank you. Thank you.